for me, I would prefer it to be horizontal. That's why I put a y equals to in front. And if I want this to be something else instead of survived, I can put, for example, sex. Right now it becomes male and female. If I want, say, for example, P class, maybe to become 1, 2, 3. Okay, this is just a title, so nothing much to talk about. So it will remain as survive. Okay, and oops, continue with the next one. Here, okay, this is a little bit more complicated. So I'll just copy and paste, and then I'll explain to you what is it about. Okay, first, this is divided into four levels. One, two, three, 2, 2, 3, 2, 2, 4. Okay, 4 levels. So this is because I want to divide into 4 segments, right? The first box is the sex of our people, our data, but with a condition that they do not survive. Here is a sex distribution, but with the condition that they survived. So now I can compare. You see, I have 100 female that do not survive, but for those who survive, I have more than 200 of them. Okay, can you see the obvious difference? Ladies first, that's why they survive more. Per male, they have 400, more than 400 of them do not survive, around 100 of them survive. Okay, then we can compare with a distribution plot. Okay, you can see obviously this is much higher, and then it becomes lower when it goes to male. Okay, this is basically all what we are doing to this chart. But the thing here is this one is just filtering. Okay, filtering survive on equals to 0, survive equals to 1. This is a distribution plot we use to put the survive and do not survive in one box here. Okay, that's why this part is longer, slightly longer. This part is our last plot over here. Okay, so let's not go put too much time in this plotting. If you want to apply this in your work, in your own data, you can just copy and paste and change the column names. Okay, I'll teach you how to change the names, but before that, let's calculate the survival rate. Okay, here we can calculate the survival rate in numbers. 74% of females survived, 80% of males survived. Okay, so there's an obvious difference in the distributions of survival rate. That is telling us that this feature is very, very important for our prediction. Okay, the calculation is a little bit difficult, so let's put it for another day. If we have another free workshop for this kind of calculations, how to deal with data frames, pandas data frames. Okay, if you like to get this kind of free workshop from us, do subscribe to our channel and leave your comment and suggestion to us that if you are interested. Then when we see that the demand is high, people are requesting for this kind of workshop, then we'll do a free workshop just like today. Okay, but for today we'll go through a quick one to give you a high level view instead of telling you how all the codes works. Okay. Next, it will be the same thing, okay, but this time is for embark. Okay, so I would copy this and paste and run. Okay, now you look at this. If you scroll through all of this, the process is identical, right? The code is identical. The only thing that changed is the column names. Okay, it's the column names. So yada yada, we run all of this through the same uh, ways until we reach the age distribution. Okay, since this is different, I will talk about this a little bit. This is actually identical with this part. The only difference is instead of count plot here, instead of using a count plot, I'm using a distribution plot. Okay, that's the reason why it's showing a bell curve instead of a bar chart. That's the only difference. The rest are identical. Okay, and then here, something you need to take note is discretizing the age. When we run discretizing the age, we are just now I've talked about this before, right? We convert numerical feature into categorical. When we want to do that, we are using binning, right? So we can use the function called cut in pandas library. Okay, cut by 5. So it means we cut into 1, 2, 3, 4, 5. It means this range of age I cut into 5 parts evenly. Okay, evenly. That's why I have this band. This age to this age, this age to this age, and yada yada. And then we'll calculate the survival rate of the age band. Okay, and then we would replace the age. Replace the age. Then we put an age band here. Can you see this? Right? Age band is here. And then the age band I would convert into nominal data 0, 1, 2, and 3. If they are in this range, I'll convert to 0. If they're in this range, convert to 1, 2, 3, 4, and so on. Okay, but before this, we should actually replace our missing values. Remember, we do have our missing values. So we'll go back up again to find the code for replacing missing values. Fill NA with the median age. Okay, filling up the nulls for the median age. Before that, we want to calculate the median age. So I'm going to add the calculation of median age here. Run this. Run this. Okay. The reason why the age is 1 is because I already convert into age band. Yeah, I was supposed to run this before the 1, 2, 3. So it's going to show 28. So, and 28 is around this range. Okay. But yeah, now that we have run this, we check our missing values. You can see that we already replaced the null values for our age. Okay, no more missing values here except for the age band okay, except for the H band. But no worries, because later we are going to remove this. So for the fare, there's another missing values here. So we would drop that row because it's just one row. It's not going to affect anything. So now I run this again. You see that all of them has become 417. Okay, so now that I've replaced all the missing values, I can now remove my H band feature because I'm not going to need that. I only want to, convert into categorical. So same thing that we did just now, train df dot drop, train df dot drop, and then I'll check the train df again. Okay, H has been replaced. No more H band anymore. Then I'm going to check my fare distribution. It's going to be the same thing with age, so I'm not going to repeat this. You can read my notebooks to really look into it one by one. Okay, so let's not waste too much time on this. But same thing we apply to our fare to discretize our fare. So discretize fare. I'll run this. Fare band not found. Quantile cut. Okay, we are going to use a quantile cut. Same thing, we will cut it into four. Cut into 4 pieces. Okay, then we'll run to get the fare band. Then we can check we can discretize our fare band, and we check our training data frame again. Okay, I think I need to run this. Fare band not found. Okay, it's already done. Okay, so we want to check our testing data frame as well, and make sure that this is the same with our training data frame. Okay, sibling and spouse is the same thing. Part is also the same thing. Okay, then we will skip to feature extraction. In the feature extraction, we can create new features for family size, which combines part and sibling. So because parents and child, sibling and spouse, remember you want to reduce the number of columns. So maybe we can combine them add them up to become family size. Your parents, your children, your sibling, your spouse, add them up, plus yourself, it will be family size. That's why family size equals to SIG-SP plus part plus 1, which is yourself. Okay, So let's just copy and paste into this, and we get the survival rate of family size. You can see that the family size have huge difference in data distribution from the family size. Okay, and then we can also create another feature called is alone, whether you are alone or not. All right, if family size equals to 1, which is you are yourself, then is alone equals to 1. Otherwise, it's going to be 0. Okay, so now we can drop our parse, SIP, SP, and family size. Why? Because of multi-collinearity problem. If we keep them, they are going to have high correlation with is alone. Okay, so I'm going to drop all of them and leave with only is alone. Okay, and we can also create another feature called age multiplied by class, because it might have some effect on your because your age and your class. If you are young and rich, probably you are going to survive. If you are not young and not rich, probably you are not going to survive, right? So we are going to multiply them up together. Since both of them are numerical, and then I would convert the sex into 1 and 0, female and male. Instead of keeping that as female and male for my sex, I convert into 0 and 1, right? Because I said just now that some algorithm can only take numerical values. Then I will take embark, because embark is also S, C, and Q, right? So they are string. Instead, I want to map them S to be 0, C to be 1, Q to be 2 as integer. So it's now a numerical column instead of a string. And that's what this is going to be our final data. Okay, as well as the testing data. We want to make sure both of them are in the same format. If this is string, this is going to string as well. Train and test has to be the same. Okay, then we would check for correlation. Checking for correlation, you only need one line of code, which is sns.heatmap. Okay, this heat map, we can see the correlation which are highly correlated with the others. So remember, survived, we want the correlation of survived to be high. Okay, we want the correlation to be high. Unfortunately, they are not much highly correlated one. And we have high correlation between age and age class, right? So in that case, we have a multi-collinearity problem between age multiplied by age class and the age. So actually, we should remove our age multiplied by class. Okay, but for the sake of this workshop, I'll just keep it so that you can see what is the thing that we would do for feature extraction. Okay. Now is finally the fun part, okay, and the last part of our workshop today, which is modeling. So in our modeling, very important thing to do is train test split. We want to split into training and testing set. Okay, why we want to split into training and testing set? Because like you are taking an exam, right? You are taking an exam. If I'm a teacher, I give you 10 questions for midterm exam. and I'll give you the same question for your final exam. Then you wouldn't know that whether my students really know the answer or did they memorize the midterm exam questions, right? So in that case, I would want to test my students if they really know their stuff. I shouldn't include the final exam questions in the midterm. That's why I need to split the questions out, okay, into X train, X test, Y train, and Y test. Okay, here I do not have a Y test because of the data. Okay, but yeah, usually this is what we will do lah. Okay, um, I think due to time constraint, I would just go through the code here instead of writing it out. So you can refer back to this reference anytime if you want and watch this video back anytime. Okay, and introducing the Scikit-Learn library. In the Scikit-Learn library, you can search for sklearn. Okay, you can search for sklearn. Here you have all the types of machine learning algorithms, everything we have talked about before: classification, regression, clustering, dimensionality reduction, and everything, right? Now we are looking at classification. And when you come into classification, you will see that there are a ton of training algorithm we can use. Okay, so if you click into any of them, for example, one of the algorithm that we are going to use later is stochastic gradient descent. It has very detailed explanation of the algorithm, the code, how it's going to use, the parameters, the output, what it returns, and all the other variations. Okay, so Scikit-Learn Library is a very useful resources for me and for many other people as well. Okay, so now I'm going to write this line of code out. Okay, for the Scikit-Learn Library, here, how easy we can train a machine learning model with Scikit-Learn. Remember, logistic regression is one machine learning algorithm, right? This machine learning algorithm, you can call it out with just one code, which is logistic regression, parentheses. This model will be stored inside this log rec object. When we want to train our data, we can do it as easy as logrec.fit. Okay, so when we use .fit, we are training our logistic regression with our x and y value. Okay, and then when we want to make predictions, when we want to train our model, it's just two lines of code. Set the machine learning algorithm as logrec and logrec.fit. That's all. You've trained your model. Okay, but in reality, it's not that easy. It's not that easy. This is just a basic model training. Okay. So for the basic one, this is how you can train a model. This, when you want to predict, we can use .predict method. Okay, and then we store our values here. Now you look at this. We add a code here to return our y prat. It returns an array of 0 and 1. What does this 0 and 1 means? It's either you survived or not. 0 means you did not survive. 1 means you survived. Okay? According to your X test data. What is your X test data? When we return the X test again, this is our X test. It means we are passing these instances into our logistic regression. Our logistic regression will output 0 or 1 for each instances. Okay, that's why we are going to have 417 0 and 1s here. for each of these instances, 417 instances. Okay, each of them will return a 0 or 1. Then we are going to plot a confusion matrix to see our model performance. Okay, confusion matrix is another topic for the other day, but when we are doing classification, we usually don't just look at accuracy. Okay, so but anyway, we will return the accuracy here. Accuracy equals to logreg.score to return the accuracy, 79.12% accuracy. Okay, 79.12% accuracy. Confusion matrix tells you which values you get it correct, which values you get it wrong. You see, 473 is 0, true label is 0, and we predicted as 0, 473. 232, when we predict as 1, is true value is 1. Okay, the purple color is what we get it wrong. Okay, the classification error. And we would use classification report to return the precision and recall of our model. Okay, what is precision and recall? You can think of it as another score that we use to see whether the model is good or not. Okay, so although the accuracy is 79%, if your precision is low, your recall is low, then your model is not that good. Okay, then we can check the correlation of each features according corresponding to our survival rate. Okay, so this part is when you think your model is good enough, right? The coefficient of that variable is representing the correlation with the survival rate. Okay, so this is what I meant by when you are doing machine learning, it's not all about the value you predicted here. It can also be the insights you gain. According to my model, the sex is contributing a lot to my survival rate, followed by age. The rest, P class is also contributing a lot in a negative way. Okay, is alone fair? Not so much. Okay, not so much. So it probably means that I can remove these two columns from my modeling process because these are not so important in predicting the survival rate. Okay. Now I can repeat this thing, repeat for all different kinds of model as we see a spot vector machine, Gaussian knife Bayes, stochastic gradient descent, random forest. What are these things? You can imagine as different machine learning algorithms, different models. Each of them have their own accuracy, each of them have their precision and recall. And in conclusion, if you compare the numbers, random forest has the highest accuracy as well as precision and recall for our true class. Okay, if you're interested to know more about these machine learning algorithms, it's going to take very long time to explain even each for just one machine learning algorithms. So if you're interested, let us know in the comments. Let us know, then we would consider doing another talk or workshop about these algorithms. Okay, so finally, we would evaluate our models. Okay, we will evaluate our models. We will put all the accuracy together to compare the model. Random forest is the best. Okay, random forest is the best. Gaussian knife base is the worst model. In this way, we would compare the model in terms of their accuracy, but in reality, there are a lot of other considerations we need to take note, not just about the accuracy. Okay, but let's assume that this is good enough. Random forest is our final model that we want to use. Then what's next? Then we are going to make predictions based on that model, right? So our prediction of the random forest is assigned to y pred, and then I would put this prediction into my test data frame, which is my Titanic test.csv. Remember, my Titanic test.csv actually do not have the survival column, right? That's why the survival column need to be predicted by us. So we would append the survival with the prediction. Okay, this survived column is actually the y predict that we have predicted just now, and then we'll append to the passenger ID. Okay, and then you can write this thing to your CSV or your database or whatever as your predictions of your whole modeling process. And this would mark the end of your work and mark the end of the machine learning project. Okay, any questions before we end our topic today? And please help us to fill up an evaluation form. You can provide your feedbacks to us. You can ask, so that we can improve in our upcoming workshops and talks, so that we can give more this kind of workshops and talks to you. So really appreciate your time. Really appreciate your time or staying with me for more than 2 hours. I've dragged a little bit, and the notebooks is in the description. It won't disappear anytime soon. You'll always be there. You can always rewatch this video. And yeah, have a nice day ahead. If you do not have any questions, I guess I will see you next time. Thank you so much for your attention, and have